Hi guys, welcome back. Hope you're doing great. Well, you already know me, but for the new ones, I'm Carla Solis, and this is. And we used to talk about engineering physics. Today, we're going to talk about something very usual, but we're going to make emphasis in the science behind this. Our topic is mirrors. Let's start. There are three kind of different mirrors: plane mirror and the spherical ones. The spherical ones are concave mirror and convex mirror. We saw mirrors have some specific characteristics, like focal length, distance to the object or image to the mirror. All of them had virtual or real image and radius curvature. We call image to the reflected part.
Initially, we are going to talk about plane mirror. So, what is a plane mirror? A plane mirror is a flat mirror that reflects light and produces a virtual image without the interference of an inward or outward curve. Plane mirrors, which include the common bathroom and hallway mirrors used daily, produce a virtual image at the same magnification as distance as the object they reflect. Plane mirrors are simply flat mirrors without curves. They can be made from liquid. Gallium and mercury can be used for this purpose. Regardless of material construction, however, all flat mirrors function the same way. They reflect rays of light, producing an image. It is important to know the laws of reflection in this case. First, the incident ray, the normal, and the reflected ray are in the same plane. Second, the angle of incidence is the same as the angle of reflection. Now, knowing all this, let's see an example. So we have a child located in front of a plane mirror polished on the left side that I indicated this time. I'm going to take a segment in this region of the knees and we make it affect the mirror. The white segment that you observe is the normal, and this is the angle of incidence. The ray of light, once it reaches the mirror, is reflected following the laws studied in this case. Second one, the angle of incidence is equal to the angle of reflection. Next, we are going to extend the rate of reflected light is the red segment observed. Now, we are going to take a point from the top of the child's head and we do the same procedure. That the incident rate of light is reflected following the studied law. The incident angle equal to the reflection angle. Let us extend the rate of the reflected light. Then on the right side of the mirror, we get the image of the child. This image has some characteristics that we are going to study next. That image is virtual. Virtual because it's a prolongation of the reflect rays. The child observes his image behind the mirror, but notice that behind the mirror there is nothing. That's why we say that it's virtual. Of equal size. If the child measures, for example, 60 centimeters, his image will also measure 60 centimeters. Right. The sense of the image is equal to that object, and it is symmetrical. For example, if the child is located 1 meter from the mirror, the image is also 1 meter behind the mirror. I have taken the minus sign here. By convention, if the image is located behind the mirror, we will always take the minus sign for flat mirror or spherical mirrors.
Concave mirrors are those who have the reflection point in the inside part, like this. My partner Alan is going to explain us about it with an example.
Hello everyone. Today we are going to see concave mirrors. As we know, the mirrors can produce an image if we put an object in front. Well, with the concave mirrors, it also produces an image in a certain distance, but with difference that this image is produced will be in the opposite direction. It's said in down. Like this. If we have an image in this direction, with an object, sorry, the image will be in this direction. So the problem gives us the next information. The object is 20 centimeters at the mirror and spherical mirror is 15 centimeters. Spherical mirror and our curvature radius is exactly the same. And the real size of object is 3 centimeters. Well, we are going to check. So we must find the distance mirror of the image and the magnetic nature. So the formula says that image distance is equal to object distance by focal mirror over the object distance minus focal mirror. What is the focal mirror? Well, the focal mirror is half the centrical mirror, so is 7.5 centimeters. And the other formula say the magnetic nature is equal minus the image distance over the object distance, like this. Well, we are going to start with the calculus, and the calculus gives us the next information, that the image distance is 12 centimeters of the mirror, and the magnetic nature is the minus 0.6. What is the mean? That the image produced is smaller than the first. Okay, and if we want to graph it, it looks like this. As the magnetic nature is negative, while the image also is negative, is down. Thanks for your attention, and you don't lose the next video.
Convex mirrors are those who have their reflection point in the outside part, like this.
Hello everyone. Today we are going to see convex mirror. What is a convex mirror? Well, convex mirror is the totally different, totally opposite that the concave mirror. Let's do start. As you can see in the image, we have the object in front of the mirror and the image into the mirror, like into the mirror. As we can see, the object and the image have the same direction, a positive direction. So let's start with the next example. Well, this example gives us the next information: the spherical mirror, the focal mirror, the object distance, and the size of the object. Okay, let's start with the next calculus. Now we have the organized data and formulas. Well, if you can see, are the same formulas that the other example, the last example, the concave mirror. Well, let's start to explain the calculus. Now here we have the calculus and the result obtained with the same method that the last topic of this video. Well, as you can see, we must be careful with the sign. Opposite by opposite are positive. For this reason, the result is positive. Alright? Okay. Well, follow with the graph of this. So here we have the image graphicated with a size with approximately 26.6. Thanks for your attention.
Well, guys, that's it for today. Hope it was useful. If you have any doubt, leave it in the comment box. I will solve enough doubts.